Everybody, thank you for coming to another awesome algebra adventure with Mr. Lines. Today we're going to go over section 13.7, Systems of Equations and Inequalities. You can look along in your textbook starting with page 604. So your objective here is when I give you a problem from a real world with two variables, you can write a system of one equation and one equality and solve this system to find a range of values of a variable. One definition that they have for you is this open sentence. An open sentence is a sentence containing a variable. Equations and inequalities such as 3x plus 5 equals 7 or y is less than 4x minus 9 are open sentences. So let's look back at the intersection of two equations. So the first equation in blue is x minus y is equal to -1. Now, if I solve over here using the zero method, I put a 0 in for x and I get a y of 1. If I put a -1 in for x, or if I put in a 0 for y, I get x is -1. And that becomes these two big dots down here. And then I draw my line. Notice I label my line. Notice that I have labels here in the corner of my y-axis, my x-axis, and the scale. There is a scale on here, so there's numbers on the grid to tell you how big everything is. So the next thing I'm going to look at is the equation 2x plus 3y equals 18. If I make x 0, y becomes 6. If I make y 0, x becomes 9. So I plot these 2 points, 0, 6 and 9, 0, and draw a line between them. And I can tell somewhere right around here is where they intersect. And it's looking like it should be point 3, 4. So, same two lines. This time they're both inequalities. So the x minus y is greater than -1, and my 2x plus 3y is greater than 18. So I do the same method of plotting the points, the blue dots and a dashed line representing the greater than, red dots at the intercepts, and a dashed line representing its greater than. And now, so what you're looking at here is on the red line, we want to be greater than 18. So your points you're looking at are above the line. That's what these black arrows were indicating. And for blue, since you were greater than -1, again, you're going to be above the line. So the place where these two intersect is this gray area here. All of this is now the shaded region. Let's look at one equation with one equality. So my equation is going to be x minus 1 is -1, and my inequality is going to be 2x plus 3y is greater than 18. So I have to draw a solid line for the equation, and I'm going to draw a dashed line for the inequality because it is a less than inequality, or it's actually greater than. It doesn't have an equal to, so it's dashed. It's non-inclusive. So in this particular case, the only points that are valid for the equation are these points on the line. Nothing in the gray area other than being on the line will satisfy the x minus 1 equals negative 1 equation. However, all parts in the gray satisfy the equation that is greater than 18. So 2x plus 3y greater than 18 is this entire gray area. And on the black part only, right here, is where the values are valid for x minus y equals negative 1. And we can also do this using substitution. Now, I showed you how to do this graphically. Now let's do it using substitution. So here are your original two systems. This is your system. So we call this a system. So it is one equation and one inequality. And so what I'm going to do is I'm going to take the equation, this equation right here, and I'm going to solve for either you either solve for x or y. It depends on your problem, but you can do either. In this case, I want to solve for y. So I manipulate it so that y is equal to x plus 1. And then I take this value of y and substitute it into my other equation, this y right here. I put that value there, which looks like this. So down below, you get 2x plus 3y. Oh, it's not y anymore. It's 3 times x plus 1 because this is my new y. And again, it's greater than 18. I solve this by turning 2x plus 3x plus 3 is greater than 18, and then it solves down for x is greater than 3. And if you look back, and we'll go back, you notice that my 3 is the point every time that these systems cross paths. It was always at the 3. Okay, so you can solve it numerically and you can solve it graphically. Now let's look at our first example. I'm asking you to solve the system to find the range values of y. Note I said values of y. So you're going to solve for y. You want y equals something. And illustrate your solution by drawing the graph. So these are my, this is my equation here, and this is my inequality. Let me back up. I want to color code this. The blue here is my equation, and I determine its points by putting a value for x in, and I get 9. And if I put a value in for y of 0, I get x is 9. So that allows me to plot these 2 points here and there. And that's enough to draw my solid line because it is an equation. So I draw a solid line because it is an equation. Moving on to the equation in red, the 3x minus 4y is greater than negative 8. If I put in a 0 for y, I will get negative 8/3 for x. If I put a 0 in for x, I get a y of 2. So plotting these 2 points, this is my negative 8/3 right here. And on this particular one, you could also just go from 0 to, and don't forget, you can always do a rise over run. What I did is I took this equation here and I converted it into a y equals mx plus b form, which allowed me to extract that m was 3/4. And from that I could rise 3 and run 4 and start just getting my next points. 1, 2, 3, 1, 2, 3, 4. It just keeps going up and up. All right. Now that because it is a inequality, I draw in a dashed line. And in this particular situation, the area that is less than, we're doing less than -8. So that includes the areas below here, below the red line. But because it's an equation, the only values valid for the blue line are those that are actually on the line itself. It's not an area, it's on the line. So let's look at a real world situation. Example 2 shows us a new elementary school is to have 50 faculty members. 50 faculty members. Some of these will be teachers, some are teachers, and some are aides. At this school, the teachers will earn an average of $20,000 a year, and aides are $12,000. They want us to define variables. They want us to write an expression for the total amount of money paid in salaries. They're given us certain situations in B, 20 teachers with 30 aides, and then how much is salary if you have 30 teachers and 20 aides. So that's going to use the expression from above. So the expression in A is going to drive B, and it's going to drive C, because in C I'm going to put the expression equal to 896,000. All right, so let's move forward. So on defining of variables, I'm going to let my X be the number of teachers, and remember they were making $20,000 a year, and my aides were going to be Y, and they were making $12,000 a year. So my salary expression in thousands of dollars, let's not mess with all these zeros, let's just call the variable thousands of dollars. You can do that. So then I'm just working with 20 and 12 and not 20,000 and 12,000. So my variable becomes 20x plus 12y is equal to the thousands of dollars of salary. So in the particular expression, they said they wanted to find the point when your teachers were 20 teachers, but you had 30 aides. That's what this one is. And your second one is when you had 30 teachers and 20 aides. So all you do is you remember that this ordered pair is an x, y. So I plug in, here's my x, this is my y. I'm following this expression here, 20x plus 12y. So I input 20 and then I input 30. I do the math, I get 760, but I have to remember that it's thousands of dollars. So it's 700, I misread, that's a mistype. It's $760,000. $760,000. Okay, and then for your next version, you plug in 30 for your II, you plug in 30 for your number of teachers, you plug in 20 for your number of aides, and you end up getting $840,000. So then they ask you, how many aides can you afford if you have to stay under a budget of $896,000? So if my budget is $896,000, I want to make sure that I actually just use 896, because I've defined my variable as thousands of dollars. So this is my system of equations here. Now this one you're going to say, where did this guy come from? Well, remember at the very beginning they said the total number of faculty people, the sum of all faculty was 50 people, and that was a combination of teachers and aides. So this second variable is what you're going to need. And just as a side note, anytime you're dealing with systems, if you have two variables, you're going to need two equations. If you have three variables, you're going to have three equations, and so forth and so on. If you get into very complicated work and you have four variables, you're going to need four equations to solve that. So anyway, so here are our two equations to solve for our four variables. Moving forward from these two equations, I remember I wanted to solve for the number of aides. So I am solving for y. Solve for y. So this is now what I'm going to do is I'm going to put this equation in terms of x, and that will let me have the y as the unknown. So just like we did up above, I am going to put in this 50 minus y now, and I'm going to substitute it into the equation that we started problem C with, and that was 20x plus 12y is 896. So my x is being substituted at this point right here at the 20x. And then I make this less than 896. And when I do the math and clear everything up, I get that y is greater than 13. And notice it says greater than. It is not equal to 13. It's not equal. So that means the minimum number of aides has to be greater than 13. 13, it has to be 14. So that means you'll have 14 aides and 36 teachers. All right. Check out your homework. It's homework is number 92, and it is number 2 through 10 even.